Greetings, this is MinGW64 of MediaTek Productions. So you've successfully installed and set up your DTL-H2000 development boards onto a computer, probably thanks to the video I've uploaded a while back. And I've essentially made the boards fully operational once again. And then you wanted to do something more with the development boards, such as make actual PlayStation software with it, the way the development boards were intended for. So this video is essentially a continuation of my DTL-H2000 installation video that I've uploaded a while back. But this one focuses more on the software and SDK side of things. This video will be covering about setting up the updated SDK libraries, setting up an IDE and configuring it for use with PlayStation development, and then setting up a Linux inspired build system because it's simply much better than PsyMake and batch files. And I'll cover all those things in a step-by-step manner, just like the last one, but I hope this one will be a bit more refined and therefore a lot shorter in video length. So without further ado, let's get right into it, shall we?
Okay, so we're now at the desktop of my DTL-H2000 equipped development computer, and the recording technique I use to record the desktop of this computer is through TightVNC. So I'm actually controlling my development computer remotely over my LAN network. The reason why I'm doing this is because TightVNC has a full resolution preview of the desktop that I'm controlling remotely, which I then record using Open Broadcasting Studio. So, which results in such a phenomenal desktop recording quality, as you can see. It's a million times better than, like, say, pointing the camera in front of a monitor. The only downside to this technique is that I cannot record games and I cannot record in full frame rate, which explains why this video is not in 50 FPS. But it's better than the camera thing that I talked about earlier. And I don't have a VGA capture box, and those things seem to be impossible to find nowadays. So before we begin doing some PlayStation software development with this computer, we first need to update the SDK a bit, more specifically the libraries, because the one that came with the Programmer's Tool CD is library version 4.3, and it didn't come with library references. So let's just update it, simply because it's much nicer to work with the latest version of the libraries. So we're gonna go to my file server, which contains the archive that we're looking for. Go to public share, software, old PlayStation dev kit, and the archive is called PSYQ47, which, as the name suggests, contains library 4.7 for the PSYQ/SN Systems SDK, PlayStation SDK. So before we extract the files here, we need to delete some files in the PS folder. So we head over here to our PS folder, go to PSX, and then we need to delete these two folders, include and lib. So we'll just delete that to the recycling bin. So next step is to there's also another problem with TightVNC. It's sometimes not very clean when it comes to screen updates. So moving on, we're gonna extract these two folders, which contains the updated libraries and headers. So extract them to CPS/PSX. The reason why I have to extract it like this is because drag and drop is apparently broken in 7-zip, particularly the last version that works with Windows 98, which supports the current 7-zip formats. So, well, kinda. So once we've updated the libraries, now we need to extract some documentation. So let's extract these three files. These are digital copies of the library references. The downside when you work with the base installation of the PlayStation SDK from the Programmer's Tool CD is that it didn't come with these documents, because when you receive those discs, you're supposed to be expected to have the manuals as well. Basically they expect you to have the manuals in bookbind form or bookbound form. So let's extract that to the documents folder right over here. and OK. Now, okay, we've now updated the documents and the libraries. Now we can do some compiling, but first we need to set up an IDE, and next is the build system, which will be Linux inspired, simply because that's my preference. You can use batch files if you want, but the Linux inspired make files is much better. So after we update the libraries, the next step is to install DevC++. I recommend version 5.11. It is so far the only most recent version of DevC++ I could find. The strange thing about DevC++ is that for some reason on Bloodshed Software's website they don't have this version of DevC++ anywhere there. But with a bit of googling you can find a SourceForge repository that has a 5.11 available. So I recommend that, and I recommend getting the no compiler version because we're gonna be setting up our own version of MinGW compiler. Because the compiler that would come with the 5.11 installer is for GCC 4.92, which does not work in Windows 98 anymore. We're using 4.71 instead, which is the last version of the MinGW GCC compiler to work under Windows 98. So let's open it up, and we select English. I click I agree. I don't really read the license agreement. I think only enterprises do that, I think. So we're just gonna use the default full installation, and then we're gonna set the destination folder to just the root directory, because we're gonna be setting a path to that, to our path environment variable later, and it will be easier to make the path keep the path short. So we'll just uncheck this because we're not gonna run DevC++ just yet. Now the next step is to set up the MinGW compiler, which will be 4.92, no, 4.72 I mean. So we'll just extract this to the DevC++ folder. DevC++ will automatically identify it, so it should be a plug and play thing. And extract. The reason why we need the MinGW compiler is mostly for its make program, which works reliably well and behaves a lot like the Linux make program. It's also handy to have a Win32C compiler available, just in case you want to make a small little utility to help with PlayStation development, such as data conversion and stuff like that. So once this has finished extracting, the next step is to extract the MSys environment, which is basically Linux terminal emulator that runs within either the command prompt or DOS prompt or its own bash emulator, terminal emulator. So we're gonna go up a directory here. This particular version here is from the DevKit Pro repository, simply because it's the easiest version of MSys that I can set up, and I can confirm that this version still works under Windows 98. So we'll just extract it in C. It just contains the MSys folder, so give it some time. The reason why we need this is because the makefile that we're gonna be using will use some Linux style commands such as rm for the currently only for the clean rule. Reason is that because MinGW make cannot use the del command, so you need a program that works like the del command, so that will be rm, which is the Linux equivalent of delete or del. So once that is finished, the next step is to set up our environment variables. So we go open up our good old autoexecute.bat, so edit that, and then the paths we're gonna add is C dev C++ MinGW32 bin, which is the direct path where we where the binaries of the compiler MinGW32 compiler are located. Next is C MSys bin, which contains the MSys programs or Linux stuff. Then the next thing we need to do is we set environment variable of H200 to true. This is for the makefile that we'll be using for compiling projects. So now that is done, now we need to restart the computer for the environment variables to apply. So we'll be right back in a bit. Okay, so we've restarted the computer. Now the next thing we need to do is to make sure that the environment variables are set correctly, or the path environment to be more specific. Now we go to the command prompt, then we type set, and there's our paths there: cdev, C++, MinGW32 bin, and cmsys bin. Now the next thing we need to do is to test the MinGW32 compiler, so we just type gcc. Okay, we get fatal error, no input files, which is good because we didn't specify any source files to compile. Now we need to test its make program so no target specified, so that's good, it's working. Now before we do some stuff, we need to rename as one particular file. We need to rename out MSys's make program. The reason is that because the make program in MSys is bugged under Windows 98. As in, if you have a clean rule in your makefile, which will basically delete all the all object files in your project. For some reason, it'll include your C files as part of the list of files to delete. So so it has the potential of deleting your source. So we're gonna look for make here, and then we're gonna rename it to MSys make. And then alternatively, you may want to rename MinGW32 make to just make to make it easier. So we'll just do that for simplicity's sake, or yeah, we'll just rename it to simply make. Just don't use MSys make. Also, the another problem with MSys make is that some programs such as ASMPSX cannot read its its program arguments properly when called by MSys's make program. So we've set that up. Now we just need to close down the command prompt since we don't need it. Now we open dev C++. Finally. So okay, we just set English, and then font is Courier New. For some reason the preview is a bit banged up, so I'm just gonna use Courier. Wow, this is another problem with tight VNC. It's not really very keen on display update, so just use Courier New. Never mind the preview, it looks fine in the actual editor. So you won't find MinGW32 make if you rename that program to just make, but we can just fix it by going to the compiler settings of dev C++. As you can see, it detected MinGW right away. So to get rid of that error message, you need to go to compiler options, and then we go to programs and rename this to just make, and that should eliminate the error. Now we need to make a custom compiler for PlayStation development. We're not actually going to be using the built-in makefile generator of dev C++. We only need, because we're going to be using a custom makefile, since dev C++ cannot generate a custom makefile that includes assembler source as far as I'm aware of. So we're going to go back to compiler options, and then we create a new compiler. We're just gonna call it PlayStation SDK or just CCPSX compiler. or just SN PlayStation compiler, because this tool chain is made by SN Systems. So then we're gonna add some binaries. We're gonna add the MinGW32 bin folder for the make program, so we add that. Then we add the PSSN bin folder for the compiler, so we add that. And then for C includes, we specify PSX include. This is just for to get the autocomplete to work, which is nifty when you're working with stuff. So we're just gonna type here the programs that make up the compiler. So ccpsx.exe, ccpsx.exe here for the G++. Make, just call it make. So okay, now we got the compiler option set. Now we'll try to make a sample project. Now we're gonna create a new project and make it an empty project. Let's name the project PSX test. Click, make sure C project is the default compiler, the default language. Let's just check that, and then we create a folder to save our project on, PSX test, and then we save it here. Okay, now we can write our first C file. So we'll type in a very simple hello world. What the heck? Oh, turns out Korea New is broken, so we should have changed the font to, gotta change the font to Courier. Korea New is bort. We'll select, we need to reselect it here. There we go, that fixes it. The initial setup for some reason is warped. So standard IO.h. We're not really gonna make a hello world yet, just something to test if the compiling will work. So this is not what a hello world program on the PlayStation looks like. And this is just a little compiler test. Okay, so we save that. Control S. Save it as main C. Now, since we won't be using the built-in makefile generator of DebC++, we're gonna be using a custom makefile that I've written, which you can find in the PSX Dev forums, and we're gonna go over there using, oh my gosh, Internet Explorer. So, well, it's still buggy as hell when it comes to loading current websites. But it's good enough to load the PSX Dev forums. For some reason, the MSN website still works under IE6, which is mighty impressive. Or it's just that Microsoft, for some reason, still supports IE6 on some websites. Probably because there's still some people somewhere on this world that still use Internet Explorer 6. So here's the forum thread that has the makefile that we want. Oh my gosh, the scrolling is terrible. With actually the scrolling looks broken under Type B and C, but it looks fine under the real computer. So never mind that. We're just gonna click select all, right click copy, and then we go and create a new file. So add it, right click, then paste, and then we save it as a makefile, just makefile. But for some reason DebC++ will always put the .c at the end. Yep. So we need to close that so we can rename it, and rename it to just makefile. And then we open that up. Dev C++ can actually highlight make files, but it's sometimes a little bit broken, as you can see here. Proper highlighting stops there for some reason, probably because it thinks this one is a comment. And I don't think it'll ever be fixed because Dev C++ hasn't been updated for years. Before we run this makefile, we need to fix the tab stops on this, because the forums ruined the tab stops, and you have to make sure that these tab stops are correct, otherwise you'll get a make error. So okay, I think that's enough. So we save that. What did I do? Oh, I deleted a line. So save that. Now we need to go to project options, makefile, check this for custom makefile, and then we select our makefile here, and then click OK. Then it should no longer generate its own makefile. Dev C++ should no longer generate its own makefile for compiling. Instead, it'll use this makefile that we copied from the forums. This is my makefile. You don't need to modify anything other than fixing those tab stops. Everything is essentially plug and play. So we need to compile by pressing F9. Let's see if it'll work. Okay. There we go. Now it has compiled our CPE file, which is a developer version of the PlayStation executable format. I imagine the reason why Sony made the development infrastructure like this when it comes to PlayStation development is so that, because the CPE file is a CPE file and not as exe file, and also Sony does not provide documentation of the file format of this of the CPE format file. We're just gonna just go there. Don't need Internet Explorer anymore. Is that when a project gets leaked and then the project only has CPE files, no one can run it on PlayStation because they don't have a tool to convert the CPE file to exe unless they have the SDK. Nowadays, you can easily find a clone of the CPE to X program and basically convert any CPE to exe, no problem. So okay, now that the make script is working, for the heck of it, I'm going to write a hello world program, a proper one for the PlayStation, as a little bonus for this video. So on to the montage. Okay, I think that's pretty much it for this putting together this hello world program, and should be good enough for execution. So yep, it's pretty much ready. So let's see if it'll compile. I hope it will. So F9. Oops. So looks like we get an error in I missed that typo. It's so hard to write a program through type VNC because it's so lagged. That's why. So let's try again. Okay, So it has compiled successfully, so the only error was just that typo there. So now the next step is that we're gonna be now that our build system is functioning and we already have a compiled program, let's go and run it on the on the development board. So now we need to load up the file server first. I hope the computer doesn't hard reboot when I run it. Sometimes that happens with this on this Dell for some reason. So SN file server, and of course the computer rebooted. Oh well. Okay, I've now got the SN file server up and running now because when I tried to run this earlier, while it was initializing the development boards, it caused the computer to blue screen so hard it caused the computer to restart for some reason, which is unusual. That's the thing about my development computer. Sometimes when you load up the SN file server, you'll either get a non-fatal blue screen, a restart, system restart, or the program will run just fine. In most cases it loads up fine. So now we want to run our Hello World program, but you can either run it using the SN file server directly by using the run CPE option, but you can also use the debugger too. The debugger would be the more preferable option because it will allow you to debug your program if there are any bugs in your program. So here's the SN debugger. Now we just put it in full window. Now we go to files, since this is a new profile, blank profile. So let's add our psxtest.cpe file, and then check that. So check download when project is started, so that the debugger will load the CPE file into the development boards when you open up the debug project. Then add one more file, the symbols file, so that the debugger can translate memory addresses into symbols, so we could easily look up variables or jump into functions. So close that, and it also allows us to step through source code line by line. So we'll just save our profile debug project. So I'm gonna name it PSXTest. Now the next thing is we need to reopen the project, so the debugger will load the CPE file into the development boards. Okay, it's now loaded, and then when we go create a new window and we change it to source view, and okay, we have our source there, source view. Now you can also do line by line debug here, but when you're gonna line by line at the start of the program, you cannot line by line by pressing F7. You need to set up a breakpoint at some spot, then run, then it will stop at that breakpoint. Because if you just step by step right away, it will go into an infinite loop. So give me a sec while I turn on the TV so I can show you the output of the development boards as we run the Hello World program I wrote. Okay, an output of the TV should be a video of the TV displaying the output of the DTL-H2000 should be up by now. And then, so if we press F9 to run the program, okay, we got Hello World, but the screen is flickering like crazy. Well, that's because we do see Hello World. The flicker reason for that is because we did not clear the frame buffer when we are gonna draw a new frame, since this is a double buffer setup. So we gotta stop the program so it won't flicker much longer. So we need to add a clear rect function to clear the frame buffer. So we need to create a clear variable, which will be the parameters to specify to the clear rect function. And it's so dodgy to type through through a VNC remote client, because of the lag. So clear image, we specify clear. We're gonna make the clear color green, so we specify 63 for green. Clear.y. This way, so that the clear image rectangle will follow the draw buffer. Clip and Y. Okay, now we press F9 to compile. Okay, now we stop since the program is stopped. To make sure that the program will run no problem on the development boards, we gotta reboot it before we reopen. The reset option isn't very useful in this setup. I think the reset option in the debug menu is only useful if you have the H2500, which doesn't need to reboot, like load a system patch, like you're seeing here in the output or something. But anyway, when you start the SN file server, it will load a special CPE file prior to becoming usable. So we reopen, and then when we run, we get now a nice hello world message on the TV with the green background. So our hello world program is now functioning properly. So that will be it for the preview. So yeah, with the if you've used a debugger before to debug your programs under Windows, for your Windows programs, this is essentially the same thing. You can step by step through your source code, and let's put a breakpoint here so we can stop the program at this exact point of the program, and we can step through. We can step into functions, and also at the same time see CP processor register status and processor registers, and then the real-time live disassembly of the piece of code that we're currently on. It's quite interesting to see a C program in assembly, but this looks like a jumbled mess because assembly spills out a lot of instructions for a very simple operation, which explains why when you want to get the best performance on the PS1 or any slow computer, whether it be a 386, you must go hardcore assembly. It's also much smaller too, so with a debugger you can also view watch variables. And why don't we try splitting this view vertically? Wrong. Oops, never mind. It's still okay. So change pane. I wanted the horizontal, so we can watch variables. You can add a watch here. So let's watch the display environment values. You just go here, and we could expand it by pressing space on here, and then we could create another watch active, and we change that to a decimal value. If we run these values will actually update in real time as you step, but it does update while the program is running, but not very frequently, because the program is running too fast for the program for the debugger to keep up. But basically, as you can see, every time we go through the display function, it will toggle active to 1 and 0 to basically swap between buffers. So 1 0 1 0, and there you go. That's basically what the debugger does, essentially. Also, all your printf messages will be output through the SN file server. And also, when you're making a writing a program that you want to debug on the DTL-H2000, you must have a line that calls the function poll host. Actually, this is a macro in the libsn header, which basically is if we stop here, press F5, and then we run, it's basically a macro to execute a break instruction of with a code of 400. What this does is that it allows the debugger to synchronize with your program, but because if you don't have poll host being called in very long loops like a main loop of your program, the debugger will lose sync, like I've demonstrated in the last video I've uploaded. So, reason for these if-def cases is that if the H200 environment variable is specified, my makefile will define a H2000 definition, which you will use to be able to make the program compile with poll host. Reason for this is that if you're compiling your program on a system without a DTL-H2000 debug system, like say a modern computer, it'll compile without the poll host macro, because if you run your program on a real console and even emulators and it encounters this break instruction, the program will simply crash with a break instruction program exception. So also every time you bring your program from the H2000 to your modern computer to continue development there without the need of a debugger, you need to recompile your whole program. So yeah, that's pretty much it for the debugger, and also some things to consider when debugging with the SN debugger. So also with my makefile, it will also compile assembly source if it finds any files with a .s extension, and then you can also debug through them in source form, line by line. And then okay, so that's pretty much it for the debugger. And the at this point your development environment is pretty much ready to go. You can now compile, you can now edit source code using DevC++, compile using a Linux inspired build system, and then debug them with the SN debugger. So it's pretty much complete at this point. Also, one last step is I'm going to demonstrate using MKPSXISO very briefly to create ISO images with my makefile. So before we do that, we have to first get MKPSXISO, and we already closed on the debugger, and then close on the file server since we don't need that. Let's go to my file server, Windows Server back again, and go to software, old PlayStation Dev Kit, and I have my MKPSXISO program here, which is inappropriately in the old folder because this program is actually made very recently, and I actually made this program. So I'll open it up, and then we will we'll extract MKPSXISO, MKISO XML. MKPSXISO, as the name suggests, it generates PlayStation ISO images. So we'll just place it in the PSX bin folder there, and then we'll extract the example program onto our PSX test program, because it'll be our template for making ISO projects. So yeah, as the name suggests, this is a PlayStation ISO maker, and it's not like MKPSXISO. It also has special functionalities such as integrating XA audio data correctly, as well as FMV videos, but I'll be covering those in a different video. MKISO XML basically parses through a directory structure and generates an ISO XML project we can use. You can use as a base instead, but it's a very bare base. So we'll open the PSX test folder. It does open. Okay, so I got our example.sml. So we just rename this to ISO.xml. This will be our ISO generator project for generating ISOs. So the next step is to modify this. This is the only time where you need to modify the makefile, unless you have other things you need to modify, such as additional source directories, include directories, library directories, etc. Now we just need to recompile. Oh wait, we don't need a recompile step. I'm getting tired of with working in this video. This is why I'm a bit derp. So we remove this file. I don't need that. And we add our XML file. Wrap it up. So yeah, this example ISO has a lot of instructions. So I'll just clear that, and then we'll just name this ISO.bin, and then name the ISO to ISO.q here. And then we're gonna create a simple data track. And then we're gonna clear the comments because we don't need those. You can read them when you use MKPSXISO yourself. Read them. So you need to specify we're gonna specify the license file. Since we have the cdgen folder which contains the license files, let's go there to make sure it's there. So it's in cdgen license file. So license a.dat. This is not really necessary, but it's nice to have the proper license data injected correctly with your ISO PlayStation ISO image. So we'll place that. Oh wait, just append it here because this program will actually inject the license data correctly, unlike say BUILDCD where it just doesn't inject the license data correctly like ever, and therefore you have to use a separate program. So let's specify my system CNF file. The system CNF file is basically like a boot record because it contains information of what executable to load. So we're gonna create a new file, create the system.cnf file. So a system CNF file is basically a small ini style file but with a .cnf extension. So we type boot, and then our program will be called then cd-rom. The program will be called psxtest.exe. We're using exe extension because my makefile will convert the CP file into an exe file appropriately when you build an ISO with it. Now we specify number of task control buffers. I will specify 4. Number of events 10, and then the stack address will be in 801FFFF0, which is at the top of the PlayStation's 2 megabyte memory range. So we'll call this system just system. We're gonna rename it again because Dev C++ will always have .c on it. So CPE and CNF. Windows will identify it as nothing, but in XP it will be identified as some speed dial file, which is incorrect. So once our system CNF file is ready, that line is already correct. Not really correct. We'll just change that a bit, and then we include our executable, which will be called psxtest.exe. Then psxtest.exe, and then there's one last thing. We need to just clear these, and we just leave we specify dummy sectors, and that's a feature in my MKPSXISO program where it will just output blank sectors, which you may need to do to prevent a so-called drive runaway, where sometimes when you seek to a sector that's near the very end of the disk, it'll cause the lens assembly of the drive to run away and RAM at the far end of your disk drive, which you don't want it to happen. You can change these options if you want, so we're not going to do that. since we're not really going to use the ISO. I'm just going to demonstrate building an ISO with my makefile, which is part of this kind of development setup. So PSX test. So to build an ISO with my makefile, you use the ISO rule. So we make ISO, enter. Then it'll generate the ISO file quietly, since we got the because my makefile by default will generate we'll call MKPSXISO quietly, so you'll have a clean build log. But if we dir, we have our ISO there in bin and Q files as bin and Q files. You only need the Q file if you have audio tracks in your ISO project. So that's pretty much redundant. So, and then you can just generate ISOs with it by specifying an .iso extension. So yeah, that's pretty much it for this video. At this point, your development system is pretty much complete. You can edit source code with dev C++. I don't know if I forgot to mention with that. Compile programs with Linux-based or Linux-inspired build system, or Linux style, whatever you want to call it. And then we can debug them with the SN debugger. And then finally we can make ISO images of our game projects. So it's pretty much all-in-one development environment. So yeah, that's pretty much it. And I hope you found this video very helpful with setting up your own development environment. All the files that I've mentioned in this video, links to them can all be found down in the description. So yeah, if you I hope you enjoyed this video. I'm pretty tired at this point right now. So if you want, leave a like, comment, or share this video if you want, and maybe even subscribe if you don't mind, or want to see more videos from me. And as always, thanks for watching. LameGuy64 is signing out, and have a good day.